Okay, we are about to start solving the third set for 2024, and this is a mathematics 10. So let's start with the section A. And section A, this consists of 20 questions of 1 marks each. The first question is the pair of linear equations x plus 2y plus 5 is equal to 0. Let's write down the pair of equations. And in this, A1 is 1, B1 is 2, and C1 is 5. The next pair of equation is minus 3x. This should be minus 6y plus 1 is equal to 0. And here A1 is A2, sorry, is minus 3, B2 is minus 6, and C2 is 1. And if we compare the coefficients, A1 upon A2 is 1 upon minus 3, which is minus 1 by 3. And B1 upon B2 is equal to 2 by minus 6, which is minus 1 by 3. Sorry, it's B2 is 6. So B1 upon 2 by minus 6. So A1 upon A2 is equal to B1 upon B2, and let's calculate C1 upon C2. So C1 upon C2 is 5 by 1, 5 by 1. And so in this case, A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. So A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. So that means these pair of equations will form parallel lines. This is the condition of the parallel lines. And when the lines are parallel, that means they will never intersect. And if they do not intersect, we will not get the solution. That is no solution. So no solution is the correct answer for this. Moving on to question number 2, we have to find the common difference for the given AP, and we know that we can find the common difference by subtracting uh, any of the two terms. So let's subtract 1 minus 4x minus 2x, that is the second term from the first term. So this is equal to D, common difference. And if I take LCM, this is 1 minus 4x minus 1, 1, 1 gets cancelled. This is minus 4x by 2x, x gets cancelled, and this is minus 2. So minus 2 is the common difference. For question number 3, two dice are thrown together, the probability that they should different numbers. Now the total outcomes, this is question number 3rd. Total outcomes when two dice are thrown is 6 squared, which is equal to 36. And the probability of getting the same number on both the dice, that is the doublets. So the number of doublets are 6, and the doublets are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So these are the doublets. So probability of getting these are the doublets, that is the same numbers. So probability of getting, if I can write same numbers on two dice, is 6. So this is 6 by 36, which is equal to 1 by 6. And now probability of getting different numbers on both the dice. So probability of getting different numbers should be equal to 1 minus probability of getting same numbers. So this is equal to 1 minus probability of getting the same number is 1 minus 1 by 6, which is 6 minus 1 by 6. That is equal to 5 by 6. So 5 by 6 is the correct answer for question number 3. And for moving on to question number 4. For question number 4, it's given that the probability of guessing the correct answer to a certain test question is 1 by 6. So probability of, I can say, the correct answer is x by 6. And the probability of not guessing the correct answer. So probability of not guessing correct answer is equal to 1 minus probability of guessing correct answer. And that is 1 minus x by 6. Okay, but this probability of guessing the correct answer is 1 minus probability of not guessing the correct answer is 1 minus probability of guessing the correct answer, which is 1 minus 5 by 6. But according to this question, it's given to us that is 1 minus x by 6 is given, which is 2 by 3. So let's equate these. So this is 2 by 3, 2 by 3, and x by 6 is equal to 1 minus 2 by 3. So this is 3. 3 minus 2 is equal to 1 by 3. 3 2 plus 6. And x is equal to 2. So the value of x is 2. That is the option A. Moving on to question number 5. For question number 5, it's given that A. So A is equal to 2 square into 3 raised power x in okay, so A is 2 square into 3 raised power x and B. So this is question number 5, and B is 2 square into 3 into 5, and C is equal to 2 square into 3 into 7. And the LCM of A, B, and C. So LCM of A, B, and C, that is 3780. So let's find out the LCM of A, B, and C. So LCM of A, B, and C, 2 square is common, so it's 2 square. And among 3 factors, we have to take the highest one, which is obviously 3 with some power, and all that is left is 5 into 7. So this is 3780. Now if I factorize 3780, so it's 2 1, 2 8 are 16, 2 9 0, and that is 2 9s are 18, 2 4s are 8, 5, and after that it's 3, 3 3s are 9, 3 1s are 3, 15, 3 105, 3 3s are is 9, 3 15, and it is 5 into 7. So for 3780, I can write its prime factors, and the prime factors of 3780 are 2 square into 3 cube into 5 into 7. And if I compare these two sides and compare the coefficients, that is the powers of prime factors, so x is equal to 3. So this gives me value of x. So x is equal to 3. And for question number 6, we have to find the zeros of the quadratic polynomial. So let's find out the zeros of the quadratic polynomial. So question number 6, it's 2x squared minus 3x minus 9. And A is equal to 2, B is equal to minus 3, and C is equal to minus 9. And if I multiply A with C, so this is 2 into minus 9 is equal to minus 18. So multiplying this, so getting the factors of 18 minus 18, these are minus 6 and 3, so minus 6 into 3 is minus 18, and minus 6 plus 3 will give me minus 3, which is the middle term. So this is 2x squared minus 6 plus 3x minus 9. Okay, 2x. So this is 2x and x minus 3 plus 3 into x minus 3. And here the common is x minus 3, which gives me x plus 3. So if I put x minus 3 is equal to 0, so x is equal to 3. or for this x is equal to minus b by 2. So our factors are x is equal to 3 and x is equal to minus b by 2. That is the option A. Moving on to question number 7. It's given that from a point on the ground, which is 30 meter away from the foot of a vertical tower. So this is the vertical tower, and the angle of elevation from this is 60 degree. And this point is 30 meter away from the foot of the tower. We have to find the height of the tower, so we can use the tan ratio. And if I put tan, so this is tan 60 is equal to AB by BC, and tan 60 is the root 3. AB is not known, BC is 30. If we cross multiply this, which gives me AB is equal to 30 root 3 meter. So option is option B. Moving on to question number 8. For question number 8, it's given that cos theta is equal to, so cos theta is root 3 by 2, and we know that the angle for which cos is root 3 by 2 is cos 30. So that means theta is equal to 30 degree. And the next is sine phi. So given that sine phi is equal to pi of half, and the angle for which the sine is half is sine 30. So that means phi is 30. And now we have to find tan. This is tan theta plus phi, which is equal to tan of 30 plus 30, which is equal to tan 60. And we know that tan 60 is equal to root 3. So root 3 is the correct option. Next one is question number 9. We have to find the maximum number of tangents that can be drawn to two circles intersecting at two distinct points. So two circles intersecting at two distinct points will be like this, and we have to find the maximum number of common tangents. So one common tangent will be here, and one common tangent will be here. So there are maximum of two common tangents. So this is option C, 2. 2 can be the maximum number of common tangents that can be drawn to two circles intersecting at two distinct points. Let's move on to the next one. For question number 10, it's given that PT is a tangent to a circle with center O, and angle TPO is equal to 35 degree and the measure of angle X. Now this 10, this angle OTP is 90 degree because the radius is perpendicular to the tangent at point of contact. Now this is 90 degree, and angle X is an exterior angle. This is an exterior angle, so this is equal to angle T plus angle P, and we know that the exterior angle is equal to sum of interior opposite angles. And angle T is 90, angle P is 35, so this is equal to 125. So 125 degrees is the correct option. And moving on to question number 11, it says that if the diagonals of the quadrilateral divide each other proportionally, then what it is, what type of quadrilateral it is, and the answer is trapezium, because we know that for the diagonals to divide each other proportionally. So let's say this is a quadrilateral ABCD, and it's given that AU upon OC is equal to OB upon OC, and we have proved this on the trapezium. This is a question. We can easily prove this if we draw the perpendicular parallel OE. So this gives me AE by ED is equal to AU by OC. This is the first result by the BPT theorem. And now if it's a trapezium, so EO is parallel to DC and DC is parallel to uh, AB. So I can also use this. So this is A upon ED is equal to AO upon OC. And now EO I have drawn it parallel to DC, but DC is parallel to AB, so that means EO is parallel to AB. So what I have done here is that EO is parallel to DC. This is by construction, but DC is parallel to AB because AB is a trapezium, ABCD is a trapezium, ABCD is a trapezium. So gives us that EO is parallel to AB. So if EO is parallel to AB, so we can use the BPD theorem, which gives me AE by ED is equal to OB by OD. So this is one. From 1 and 2, we can get that AO by OC is equal to OB by OD. So this happens only when AB and CD are parallel. So AB and CD are parallel, so that means it's a trapezium. So when the diagonals are divided proportionally in a quadrilateral, so that means it is a trapezium. Okay, for question number 12, it's given that in triangle ABCDE is parallel to BC, so that means angle 1 is equal to angle 2 and angle 3 is equal to angle 4 because these are corresponding angles. So angle 1 is equal to angle 2 and angle 3 is equal to angle 4 because these are corresponding angles, and we know that corresponding angles are equal, which makes triangle ADE similar to triangle ABC, and these are similar by A rule. And if the triangles are similar, so that means AD upon AB. So AD upon AB is equal to BE by BC. And AD is 2, BD is 3, so this is 2, 3, which gives me AB as 5. So AB is 5, and DE we have to find out. BC is 7.5, this gets cancelled with 5, so this is 1.5, and which gives us D is equal to 6 centimeters. So the option is correct, option D. Moving on to question number 3. Now the HCF and product of two numbers. We know that HCF into LCM is equal to the product of two numbers. So HCF is given as 40 and LCM is 252 into K, and the two numbers are 2520, 2520 and 660. So HCF of 2520 and 660 and LCM of 2520 and 660 is given. So this is 10, and if I divide this by 4, so it's a 4 1s are 4, 4 6 are 24, 4 5 are 20. That gives you the value of K as 1650. So 1650, that means option A is the correct answer. Let's move on to next question. That is question number 14. Okay, for question number 14, we have to find the pair of irrational numbers whose product is a rational number. So if I consider the first one, which is root 16 and root 4. So root 16 is 4, which is not an irrational number. So it is not an irrational number. Root 4 is 2. So both these two are rational numbers. So we are not going to consider this. For B, root 5 is irrational, root 2 is irrational. And if we multiply them, root 5 into root, which is root 10, and this is irrational, but it has to be irrational. So this is also not the option A and B. Moving on to option C. Root 3 is irrational. Root 27 is irrational. So root 3 into root 27, that is equal to root 81, and which is equal to 9, which is rational. So our correct option is option C. root 3 and root 27 are irrational, but the product is rational, which is 9. Now moving on to question number 15. For question number 15, we are given with the random digits 1, 2, 3, 4, 5, 6, 7, 8, and 9. And these are total of 9 digits. We have to find the probability of odd prime. Now, odd prime 1 is neither prime nor opposite nor composite. So 1 is not the odd prime, 3 is the odd prime, 5 is the odd prime, and 7 is the odd prime. So these are total of 3. Outcomes are 9. So this is 1 by 3. So 1 by 3, option A is the correct option for question number 15. Moving on to question number 16, the mean of 5 observations is 15. So let the 5 observations be x1 plus x2 plus x3 plus x4 plus x5, and mean is divided by 5, which is 15, which gives me the sum of the observations, first 5 observations, x3 x4 plus x5 is equal to 75. Let me be first set of equation. Now the mean of first 3 observations is 14. So that means x1 plus x2 plus x3 divided by 3 is equal to 14. And this is now x1 plus x2 plus x3 is equal to 42. This is second equation. Now the last 3 observations, that is x3 plus x4 plus x5, is its mean is 17. So which gives me x3 plus x4 plus x5 is equal to 51. So let this be third set equation. And if I put this x1 plus x3 plus x4, that is the value of last 3 observations in this first 3. So this is 51, which gives me, so this gives me x1 plus x2 is equal to 75 minus 51. So the first 2 observations, sum of the first 2 observations is 24. And if I put the sum of the first 2 observations here, that should give me the third observation. So here x3 is equal to 42 minus 24, which is 18. So 18 is the correct option. Moving on to question number 17, we have to find the perimeter of the circle. So perimeter of the sector of a circle. So let this be a circle with sectors having a radius 7 centimeter and a 7 centimeter, and the central angle being 90 degree. So we have to find the length of the boundary of the sector, that is the 2 radii. So here the perimeter of the circle is 7 plus 7 plus, and the length of this arc is given by theta by 360 into 2 pi r. So 7 plus 7 is 14. Central angle is 90, 90 by 360 into 2 into 22 by 7 into 7, which gives me, this is 4, this is 2, 11, and 14 plus 11 is 25 centimeters. So D is the correct option. Moving on to question number 18. For question number 18, it's given in the given figure, O is the center of the circle, MN is the chord, and the tangent ML at point M makes an angle of 70 degree with MN. So here for question number 18, now OM is perpendicular to ML. The reason being radius is perpendicular to tangent at the point of contact. The radius is perpendicular to tangent at the point of contact. Now, so that means angle OMN is equal to 90 minus 70, which is equal to 20 degrees. So this is 20. Also, OM is equal to ON. These are the radii of same circle. And radii of same circle means angle OMN is equal to angle ONM. This is equal to 20 degree because these are the angles opposite to equal sides. And we know that the angles opposite to equal sides are equal. So this is also 20 degree and we have to find angle MON. So using the angle sum property, angle MON is equal to 1 minus the sum of the other two angles, which is 40. So this is 140 degrees. So 140 degree, that is B is the correct option. Moving on to question number 19 and 20. Okay, for question number 19, it's the assertion and the reasoning based. The point which divides a line segment joining the points is internally in the ratio 1 is to 2 is. So let's say this is the point A, 1 comma 2, and point B is minus 1 comma 1, and both these are joined. Let's say the point B divides the join of A and B in the ratio 1 is to 2. We have to find the coordinates of P using the section formula. So coordinates of P using the section formula is m1 into x2 plus m2 into x1 upon m1 plus m2. So this is P, comma m1 y2 plus m2 y1 upon m1 plus m2. And if I put in the values, this is m1, this is m2, and these are x1, y1, and x2, y2. So m1 is 1, x2 is negative 1, m2 is 2, x1 is 1, m1 plus m2 is 3, m1 is 1, y2 is 1, m2 is 2, y1 is 2 upon 3, which gives us the coordinates minus 1 plus 2 by 3 and 1 plus 4 by 3. So this is 1 by 3 comma 5 by 3. So 1 by 3 comma 5 by 3 is the option, are the coordinates of P, which are not matching with our solution. So this is false. But the reason is true because we have used this formula. So assertion A is false, but reason R is true. That is D is the correct option for this. For question number 19, it's D. Assertion A is false, but reason R is true. Okay, moving on to question number 20. And for question number 20, it's given that in a cricket match, a batsman hits a boundary 9 times out of 44 ball he plays. The probability that in a given ball he does not hit the boundary. So probability of hitting boundary is 9 out of 45, and probability of not hitting the boundary is 1 minus 9 by 45. So that is 45, 45 minus 9. 15 minus 9 is 6. So that is 36 by 45. And 6, 6, that is 36. So it's 9, 4, that is 36. And 9, 5, that is 45. So it's 4 by 5. So which is true. So this is true and this is the correct explanation. So both assertion A and reason are true and reason R is the correct explanation. So for this, the correct option is A. Okay, moving on to section B. Okay, for section B, this section consists of 5 questions of 2 marks each. And let's try to solve the first one, which says one card is drawn at random from a well-shuffled deck of 52 cards. And we have to find the probability that The card drawn is Queen of Hearts. So total cards in a deck of cards are 52, and we have to find the probability that it is Queen of Hearts. Now there is only one Queen of Hearts, so this is 1 by 52. And for the second one, we have to show that it's not a jack. Probability of not a jack. Now the total jack are 4. So 52 minus 4 is 48. The non-jack cards are 48. So this is 48 by 52. And which gives me 24 to 6, 12 and 13. So the probability is 12 by 13. Okay, for the next question, that is question number 22, we have to solve the set of equations, and the set of equations are 2x plus y is equal to 13. Let this be first set of equation, and 4x minus y is equal to 17. This is the second set of equation. And we have to find the value of x minus y. So to find the value of x minus y, let's find out x and y first. So I'm going to multiply the first equation with 4 and going to multiply the second equation with 2. So this is 8x plus 4y is equal to 52. And this is 8x minus 2y is equal to 34. And okay, so this gets cancelled. 4y plus 2y is 6y. 12 minus 4 is 8. 4 minus 3 is 1. So y is equal to 3. And if once again I multiply these equations, the first one, or let me just add them. Let me just add these two equations. So if I go ahead and add these two equations, so adding these two equations will give me 2x plus 4x is 6x. This gets cancelled. 13 plus 17 is 30 and gives me x is equal to 5. Now we have to find the value of x minus 5. So x minus y is equal to 5 minus 3 is equal to 2. So x minus y is equal to 2. And now let's jump on to part B, which says the sum of two numbers is 105 and the difference is 45. We have to find the numbers. So let the greater number or the largest of them be x and smaller number be y. So according to question, sum of the two numbers, that is x plus y is equal to 105, and the difference, that is x minus y is equal to 45. These are the two sets of equations, and I'm going to add that, which gives me 2x is equal to 1. This is 50 and x is equal to 75. So x is equal to 75. And if I once again subtract these equations, that will give me the value of y. So x plus y is equal to 105 and x minus y is equal to 45. If I go ahead and subtract these equations, so this cancels out x, and 2y is equal to 60, so y is equal to 30. So the two numbers are 75 and 30. So I can write down that the numbers are 75 and 30. Okay, moving on to the next question, that is question number 23. Let's move on to question number 23. Before question number 23, we have to find the relation between x and y such that the point P is equidistant from the points A and B. Now the distance of point B, so according to question, the distance of point B from A is PA and from B is PB. And using the distance formula, we can find out PA, which is square root of x2 minus x1. So this is 7 minus x the whole square plus 1 minus y the whole square. And this is PA. So this is square root, and PB is 3 minus x the whole square plus 5 minus y the whole square. So square root gets cancelled. If you square on both sides, this is a minus b the whole square, which is a square plus b square minus 2ab plus a square plus b square minus 2ab once again. And this is a square plus b square minus 2ab plus a square plus b square minus 2ab. Okay, so x square gets cancelled, y square gets cancelled. And finally we have, let's shift all these to the left hand side to get the relation. So minus 9 plus 6x minus 25 plus 10y is equal to 0. Now minus 14x plus 6x is minus 8x, minus 2y plus 10y is 8y, and 49 minus 9 is 40, and 40 minus 25 is 15. So this is plus 15 is equal to 0. And the equation that I have got here is, okay, so this is 49 minus 9 is 40, and this is 7 square 1. Okay, we just left a 1, so there is 1 as well. So if I add 1, so this is 16, which gives me 8x minus 8y minus 16 is equal to 0, and 8 is common, so x minus y minus 2 is equal to 0. So finally we have x minus y is equal to 2 is the relation between x and y. Okay, for next one, it's given that the next question, that is the part B. And for part B, it's given that points A minus 1 comma y and B 5 comma 7 lie on a circle with center O, so that AB is the diameter. So let's say this is the circle with center O. Okay, now points A. So point A is minus 1 comma y, and point B is 5 comma 7. They lie on a circle with center O, and center O is 2 comma minus 3y. And now AB is the diameter. AB is the diameter means O is the midpoint, and we know that to find the midpoint, formula is x1 plus x2 by 2 plus y1 plus y2 by 2. That gives us the coordinates of A. Okay, let's replace the values. So this is x comma y, and these are x1 y1. This is x1 y1, and this is x2 y2. Now x1 is minus 1, x2 is 5 by 2, y1 is y, y2 is 7 by 2. So this is equal to, the coordinates on the center are 2 comma minus 3y. Okay, so this is 4 by 2 is 2. This is y plus 7 by 2 is equal to 2 comma minus 3y. So let's equate the y coordinates to get the value of y, and we have to find the radius of the circle as well. So y plus 7 by 2 is equal to minus 3y. If I cross multiply this, which gives me minus 6y is equal to y plus 7, and this is minus 7y is equal to 7, so y is equal to negative 1. So the value of y is negative 1, and now we have to find the radius. So the radius is OB. So let's find out the radius OB, which y is 1. So that means the coordinates of the center are 2 comma minus 3. And to find out the radius, let's use the distance formula. So 5 minus 2, the whole 5 minus 2 is 3 square plus, and 7 minus of minus 3 is 10. So 10 square, which gives me 9 plus 100, which is equal to root of 109. Okay. Uh, Actually, the y is 1. So the coordinate should be, this is now, if y is 1, so this should be 2 comma 3. And if it's 2 comma 3, then it's 7 minus 3 is 3 square. So 7 minus 3 is 4. So this is 4 square, which is 16. So this is root 25, which is equal to 5. So radius is 5 units. Okay. Now, moving on to question number 24. Okay, for question number 24, in the given figure, it's given, what is given to us is, it's given that EA by EC is equal to EB by ED, and we have to prove that triangle EAB is similar to triangle ECD. Now, let's try to prove that. So what is given to us is EA is in first triangle and EC is in second triangle. EB is in first triangle and ED is in second triangle. So obviously these are the corresponding sides of the two triangles which are in proportion. So we can write it as it is. And this is because the reason being it's given. Now these two angles are vertically opposite angles, and these are the included angles of the corresponding sides that are in proportion. So these are vertically opposite angles. So we can say that by SAS similarity rule, triangle EAB is similar to triangle ECD. Okay. Now we have to evaluate the question number 25. So for question number 25, let's put in the values. Cos 45 is 1 by root 2. Sine 60 is root 3 by 2. Secant 30. Secant 30 is the reciprocal of cos 30, which is root 3 by 2. So this is 2 by root 3 plus cosecant 30 is the reciprocal of sine 30, which is 2. Okay, for the numerator LCM is 2 root 2. So this is 2 plus, and this is 2 plus root 6 by 2 root 2. Okay. So the values are 1 by root 2 plus root 3 by 2, 2 by root 3 plus 2. And if we take LCM here, LCM is 2 root 2. So 2 root 2 divided by root 2 leaves us with 2. And 2 root 2 by 2 divided with 2 leaves us with root 2. So root 2 into root 3 is root 6. And here the LCM is the root 3. So this is 2 plus 2 root 3. Okay, let's try to rationalize this. This is 2 plus root 6 by 2 root 2 into root 3 by 2 plus 2 root 3. So this is 2 root 3 plus root 18 on. This is 2 to the is 4. So 4 root 2 plus 2 to the is 4 and 4 root 6. Okay, now 2 root 3 root 18 is 9 into 2. And for 4 root 6, root 4 is common. So root 2 plus root 6. And this is now 2 root 3 plus 9. Root of 9 is 3, so this is 3 root 2 by 4 is common. So 4, uh, this is root 2 plus root 6. We can further rationalize it if you want to solve. So let's rationalize it by using the denominator, by using the conjugate of root 2 plus 6. So if we multiply this, this is 2 root 3 into root 2 is 2 root 6. And 2 root 3 into minus root 6 is minus 2 root 18 plus 3. This is 6. And this is minus 3 root 12 upon 4. This is always a square plus b square, so this is 2 minus 6. Okay, and once again, this is 2 root 6. Now root 18 is 9 into 2, and root of 9 is 3, so 3 twos are is 6. This is 6 root 2 plus 6 minus 3. Root 12 is equal to 4 into 3, so this is equal to 2 root 3, and 3 into 2 is 6. So this is 3 twos are is 6, so 6 root 3 upon minus 16. Okay, so this doesn't make any difference. Let's shift this to or take 2 common. So if I take 2 common, this is root 6 minus 3 root 2 plus 3 minus 2 root 3 or minus 16, which is 2 minus 8. If I remove the negative from the denominator, this is 3 root 2 plus 2 root 3 minus root 6 minus root 3 by 8. This should be the final answer, but I would suggest to leave it just here. Leave the answer here. 2 root 3 plus 3 root 2 upon 4 into root 2 plus root 6. That should be our final answer. 2 root 3 plus 3 root 2, 4, or in this case, I can also take uh, the root 2 common, so root 3 plus 3 root 2 upon 4. If I take root 2 common, so this leaves me with 1 plus this is the root 3. So 4 root 2 into 1 plus root 3. And because this rationalizing is not making any difference, because it's not rationalizing it, and not giving us the simplest form, so I will leave this answer here. Okay, let's move on to next question, or rather the section C. Okay, for section C, question number 26, and we are going to solve part A. It's given that sum of first 7 terms of an AP is 79. So sum of first 7 terms is equal to 49. And we know the sum of 7 terms is given by n by 2 into 2a plus n. This is n, which gives me 6d is equal to 49. And this is 2a plus 6d is equal to 49 into 2 by 7. So this is 2a plus 6d is equal to 14. And if I take 2 common, this is a plus 3d is equal to 14. And a plus 3d is equal to 7. Now the sum of first 17 terms is 289. So sum of 17 terms is equal to 289. And 17, sum of 17 terms is n by 2 into 2a plus n minus 1, which is 16d is equal to 289. So this is 2a plus 16d is equal to 289 into 2 by 17, 17. And if I take 2 common here, this is a plus 8d is equal to 17 into 2. So finally, it's a plus 8d is equal to 17, and this is the second set of equation. So we have two sets of equation. A plus 3d is equal to 7, and the second is a plus 8d is equal to 17. Now, if we go ahead and solve these, we will get A. So I'm going to subtract these two sets of equation. So 3D minus 8D is minus 5D is minus 10, which gives me D is equal to 2. Okay, D is equal to 2, and if I use the first set of equation, so this gives me A plus, if I replace the value of D in this is A plus 6 is equal to 7, and A is equal to 1. So D is equal to 2 and A is equal to 1. We have to find sum of first 20 terms. So sum of first 20 terms is n by 2 into 2 into A plus n minus 1, which is 19 into D is 2. This is 10. 10 and 2 plus is 38, which is 40. So sum of first 20 terms. So sum of first 20 terms is equal to 400. Okay. Uh, let's move on to part B of, okay, for part B. Okay, for part B, is given that the ratio of the 10th term to its 13th term of an AP is 1 is to 3, and the sum of its first six terms is 42. We have to find the first term, that is A, in the common difference D. So let's write down what is given to us. This is question number 26. The ratio of the 10th term, that is A10, and to its 30th term, that is A30, is given to us is 1 by 3. So A10 is A plus 9D, and A13 is A plus 29D is equal to 1 by 3. And if I cross multiply this gives me 3A plus 9D is, sorry, 3A plus 27D is equal to A plus 29D. So 3A minus A is 2A, minus 2D is equal to 0, or I can uh, it's 2A is equal to 2D, so that means A is equal to D. Now the sum of first 20 terms is, sorry, we have to find sum of first six terms is 42. We have to find the first term and the common difference. So sum of first six terms S of 6 is 42, and the sum of first six terms is given by n by 2 into 2 into A plus n. My n is 6. So 6 minus 1 is 5, and D is equal to 42. Now this is 3. Now A is equal to D, so instead of D, I can write A. So this is 5A is equal to 42. This gets cancelled. 3 on the 3, 3 4s are 12. And 7A is equal to 14, which gives me A is equal to 2. Since A and D are equal, so A is equal to D is equal to 2 is the answer for this question. Okay, moving on. Okay, for question number 27, we have to find the zeros of the quadratic polynomial, and let the polynomial be P of x is equal to x squared minus 15. And I can write it as x squared minus root 15 square. 15 can be written as root 15 the whole square. So this is now a square minus b square, which is a plus b into a minus b. So either or the two roots are either x is equal to root 15 or x is equal to negative of root 15, and we have to find the relation between the zeros and the coefficients of the polynomial. Coefficients of the polynomial are 1, B is 0, and C is negative 15. So to verify the relationship, its relationship says the sum of zeros should be equal to minus B by A. Now the sum of the zeros is negative 15, negative 15, minus B is 0, A is 1. So this is 0 is equal to 0. So the first relationship is verified. And the second relationship says that the product of 0 should be equal to C by A, and the zeros are root 15 into negative root 15. C is C is negative 15 and A is 1. So this is negative 15 into negative 15. So this relationship is verified and hence the relationship is verified. For the next question, we have to solve the following system of linear equations graphically. Okay, for next question, we have to solve the following system of linear equations graphically, and I've got the Cartesian plane for this. So first equation is x minus y plus 1 is equal to 0. And let me get the values of x and y for this. If I put x is equal to 0 here, which gives me 0 minus y plus 1 is equal to 0, so y is equal to 1. And if I put y is equal to 0, if I put y is equal to 0 in this equation, so if I put y is equal to 0, that gives me x is equal to negative 1. So if I plot these graphs, so I have these points 0, 1. So 0, 1 is this one, and minus 1 comma 0 is this one. And if I join these 2 points, so joining these 2 points, okay, so this is the equation of the first line, and which is represented by x minus 1 plus x minus y plus 1 is equal to 0. Okay, for the next line, it's x plus y is equal to 0. So sorry, x plus y is equal to 5. And if I put x is equal to 0, which gives me y 5, and if I put y is equal to 0, which gives me x 5. So these are the 2 points, and I'm going to plot these 2 points 0, 5 and 5, 0. So 0, 5 is here and 5, 0 is here. And if I join these 2 points, so this is the graph. This is x plus y is equal to 5, and these two lines are intersecting here. So x is equal to, coordinates of these points are 2 comma 3. So these are the coordinates 2 comma 3, which gives us a solution. X is equal to 2 and y is equal to 3. So x is equal to 2 and y is equal to 3 is the solution of the linear equations. Okay, moving on to question number 29. Let's move on to question number 29. Okay, for our next question, that is question number 29, we have to find the ratio in which the line segment joining the points. So we have this line segment that is joining the points. The points are 5 comma 3 and minus 1 comma 6. And these points are A and this is B. It has to be divided by the y-axis. So if it is intersected by the y-axis, so let's say this point, we on the y-axis we know that the coordinates are 0 comma y, so let this be point P. So let point P 0 comma y, it divides the join of line A 5 comma 3 and B minus 1 comma 6 in the ratio k is to 1. So this is k is to 1, and these coordinates are x1 y1 and these are x2 y2. Okay, now if we use the section formula, so the section formula says that x comma y, the coordinates of point B are x, this is m1 x2, m1 x2 plus m2 x1 on m1 plus m2. This is m1 y2 plus m2 y1 upon m1 plus m2. Now x comma y are the coordinates of P. So x coordinate is 0. So this is 0 comma y. Now let's put in the values. M1 is A x2 is 6, sorry, minus 1, plus m2 is 1, x1 is 5 upon k plus 1. M1 is k, y2 is 6, m2 is 1, y1 is 3 upon k plus 1. And further simplification of this gives 0 comma y is equal to minus k plus 5 upon k plus 1 minus comma 6k plus 3 upon k plus 1. Now, if we equate this, which gives me minus k plus 5 is equal to 0. So minus k is equal to negative 5 and k is equal to 1. So therefore, required ratio is 5 is to 1. Okay, so the required ratio is 5 is to 1, and that's what was asked in the question. Moving on to the next one. Okay, for question number 29, part B, it's given that P minus 2 comma 5 and Q 3 comma 2, and let's join them are the 2 points, and we have to find the coordinates of point R on the line segment such that, so let's say this is a point R, this is P, this is Q, and it's given that PR is equal to 2 times QR. So that means PR by QR is equal to 2 by 1. So this is PR and this is QR. So that means the ratio is 2 is to 1. And we have to find the coordinates of the point R. So let the coordinates of the point R be x comma y, and these be x1, y1, and these be x2, y2. So we are going to use the section formula once again, and we have got the ratio m1 is to m2, that is PR is to QR, 2 is to 1. So I'm going to use the section formula. Section formula says that the coordinates of point R should be x comma y. It's m1 x2 plus m2 x1 upon m1 plus m2. It's m2 x1 plus m2 m1 x2. So let it be m1 y2 plus m2 y1 upon m1 plus m2. I'm going to put in the values, replace, substitute the values. M1 is 2, x2 is 3, m2 is 1, x1 is negative 2 upon m1 plus m2, which is 3. Now m1 is 2, y2 is 2, plus m2 is 1, y1 is 5 upon 3, which gives me the coordinates x comma y, which is 5. 5 minus 2 is 3. 3 by 3 is 1. 2 plus 2 into 2 is 4, plus 5 is 9, divided by 3 is 3. So the coordinates of the point R are 1 comma 3. Let's just check it once again. So the first one is 2, 3 minus 2. So 2 into 3 is 6. 6 minus 2 is 4. So actually that should be 2 by 3. And the next one is 3. So 4 by 3 comma 3 are the coordinates of the point R. Okay, moving on to the next question. That is question number 30, which is a trigonometric identity. We have to prove that sine theta minus 2 cube sine theta upon 2 cos cube. So this is question number 33. And LHS, which is equal to sine theta minus 2 sine cube theta upon 2 cos cube theta minus cos theta. So for numerator common is sine theta, so this is 1 minus 2 sine square theta, and for denominator its common is cos theta, so this is 2 cos square theta minus 1. Okay, sine theta by cos theta is tan theta, and I'm going to replace the sine square theta. We know that the first identity, sine square theta plus cos square theta is equal to 1, which gives me sine square theta is equal to 1 minus cos square theta. So this is 1 minus cos square theta upon 2 cos square theta minus 1. Okay, so this is equal to tan theta, and 1 minus 2 plus 2 cos square theta upon 2 cos square theta minus 1. Okay, so this is equal to tan theta. 1 minus 2 is negative 1 plus 2 cos square theta upon 2 cos square theta minus 1. This gets cancelled, which is finally equal to tan theta, and that's our RHS. Okay, moving on to question number 31. Okay, for question number 31, we have to prove that the tangent drawn at the endpoints of a circle make equal angles with the chord. So let's first try to understand what is given in the question, and let's say this is the circle, and we have to draw the tangents at the endpoints of a chord. Uh, okay, so I'm going to draw the tangents at the endpoints of the chord. So let's say this is uh, let's say this is a chord, and at its endpoint to draw two tangents. So let's say this is one tangent, and this is the other tangent. Okay, let this be the center of a circle O, and this chord be BA, and these tangents be X, Y, and X dash, Y dash. Okay, so what do we have to prove? That the tangents drawn at the endpoints of a diameter make equal angles with the chord. So these tangents are making these angles with the chord. So this angle is angle BAX, and its corresponding angle on this side is ABX dash, or it's BAX and ABX dash. So we have to prove that it's equal to ABX dash. So this is the first thing that we have to prove, and the second one that we have to prove is this angle. This angle is BAY, so we have to prove that angle BAY is equal to angle ABY dash. So these are the angles made by the chords with the tangents at its endpoint. So for this, let's join O to A and O to B, and let's draw a perpendicular, and let's say this perpendicular is M. So I have done a construction here. So construction is join O to A, O to B, and we have to draw pattern O to A. Now, so this is O to B, and now we're going to be triangle AOM and triangle BOM. First of all, this angle OMA is equal to angle OMB, both being each of them is 90 degree. Now OM is equal to OM, which is common. So this angle and AM is equal to MB. So I can write AM is equal to MB because perpendicular drawn from the center bisects the chord. Perpendicular drawn from center of a circle bisects the chord. Okay, so that means this triangle AOM is congruent to triangle BOM, and the rule here is SAS. So this by SAS congruence rule, these two triangles are congruent. Now, if these two triangles are congruent, that means angle OAM is equal to angle OBM. So angle OAM is equal to angle OBM. These are the corresponding parts of the congruent triangles. So these two angles are equal. Now, this angle is 90 degree and this is 90 degree because OA is perpendicular to X, Y, and OB is perpendicular to X dash, Y dash. Reason being, radius is perpendicular to tangent at the point of contact. Let this be our result Y. Okay, and these are perpendicular, so that means angle OAX. So angle OAX is equal to angle OBX dash. So OBX dash, reason being both are 90 degree. So I'm going to add these results 1 and 2. If I add these results 1 and 2, so which gives me angle OAM plus angle OAX should be equal to angle OBM plus angle OBX dash. So OAM. If I add angle OAM and OAX, this gives me angle BAX. So this is angle BAX. And if I add angle OBM and OBX dash, this gives me angle ABX dash. So here this is angle ABX dash. So this is angle ABX dash. So this proves our first result, which was angle BAX is equal to angle ABX dash. Now, uh, okay, this whole angle OAX and angle OA, uh, next we have to do that BAY. Now angle BAX and BAX plus BAY is equal to 180 degree. And similarly, so this is angle BAX because these are linear, these form linear pairs. So angle BAX and BAY, these forms linear pair which is 180 degrees. Similarly, angle ABX dash and ABY dash. So angle ABX dash plus angle ABY dash, angle ABY dash is equal to 180 degree, reason being these are linear pairs. So let this be equation 1, this be equation 3 and 4. So this is equation 3 and 4. So from 3 and 4, we will get that angle BAX plus angle BAY is equal to angle ABX dash plus angle ABY. Okay. But angle BAX is equal to angle ABX dash. So these two angles are equal. So instead of this ABX dash, I can write angle BAX because these two angles are equal and this gets cancelled. So finally we have angle BAY is equal to angle ABY dash. This was the second result that we have to prove. Angle BAY is equal to angle ABY dash. Okay, let's move on to next question or the next section. For section D, question number 32, first part, it's given that in a flight of 2800 kilometer, an aircraft was slowed down due to bad weather and its average speed is reduced by 100 kilometer per hour. By doing so, the time of flight then increases by 30 minutes. We have to find the original duration of the flight, that is the time. So this is question number 32, part A. And here what's given to us is distance, which is constant 2800 kilometer in both cases. Now let's say speed of aircraft be x kilometer per hour. And if distance and speed are known, so this is the original duration, which is time is equal to distance by speed. So distance is equal to 2800 and speed is x. So this is in hours. Okay, for second case, the distance is still 24,800 kilometer, and now the speed has been reduced by 100 kilometer per hour due to bad weather, owing to bad weather. So this is x minus 100 kilometer per hour. And now the new time in this case is once again distance by speed. This is hours. And according to question, there is a difference of 30 minutes in these two times. So which one is greater? This one is greater because the speed here is reduced, and the speed, if the speed is reduced, it takes more duration. So difference between these two times, that is in the second case 28 upon x minus 100 minus 2800 upon x is equal to 30 minutes, and let's convert this into hours, which is equal to half hour. So if I take LCM in this case, so this is x into x minus 100, and we are left with 2800x minus 28 into x minus 100 equal to half. Okay, so this is 2800x minus 2800x plus this is 28 with 4 zeros, and it's cancelled upon x squared minus 100x is equal to half. Now if we cross multiply this, this gives me the quadratic equation x squared minus 100x, and I'm going to write down the quadratic equation. So this is minus at 56 with 4 zeros is equal to 0. We have multiplied 2 with 28, which is 56, and 2 zeros. Now this is the quadratic equation, and I'm going to solve this using the quadratic formula. So A is equal to 1, B is equal to negative 100, and C is equal to minus 56. That is 5,60,000. And we have to find x, and quadratic formula says that x is equal to minus b root of d, which is b square minus 4ac upon 2a. And if I substitute the values, this is minus or minus 100 plus minus b square is minus 100 square minus 4 into a is 1 into minus 56 in with 4 zeros, and 2 into a, which is 2. Okay, let's try to, this is minus 100 minus 100. Okay, so minus of minus is plus, that is 100 plus minus square root or square of 100 is 10,000, minus minus is plus. 456 into 4 is 6 fours are 24, 5 fours are 20, 2 to 4 with 4 zeros divided by 2. And now x is equal to 100 plus minus. This is 2, 2, 5, 1, 2, 3, 4 under root 2. Okay, next step is 100 plus minus square root of 22 to 5 is 15, and out of four zeros, only two comes out. So this is 1500 by 2. And now we have two values for x. One is 100 plus 1500 by 2, and x is equal to 100 minus 1500 by 2. So this is equal to 100 plus 1500 is 1600, divided by 2 is 800, and here this is 100 minus 1500 is 14, which is minus 700, which cannot be the speed. So our answer is x is equal to speed is equal to 800 kilometer per hour. But that's not what is asked in the question. Read the question once again. It's the final duration. So final duration is this one, time. So final duration, that is the time, is equal to 2800 divided by 800, which is 8 threes are is 2443.5. So this is equal to 3.5 hours. 3.5 hours means 3 hours and 30 minutes. Okay, so let's move on to the next question. That is the part B of the same question. And it's given that the denominator of a fraction is one more than twice the numerator. And if the sum of the fraction and its reciprocal is 216 by 21, we have to find the fraction. Okay, so part B of 32nd, this is part B. And the denominator of a fraction is one more than twice the numerator. So let's numerator be x and denominator is one more means 1 plus twice means 2x of the numerator. Now, according to question, sum of the fractions. So our fraction becomes, this is numerator and this is denominator. So this is the fraction and it's reciprocal. Reciprocal is 1 plus 2x by x is 216 by 21. Okay, let's take LCM here. So this is x plus x into 1 plus 2x. So this is x squared, and 1 plus 2x the whole square is equal to, this is 21, and 21 into 2 is 42 plus 16, which gives me 8 and 58 by 21. Okay, so let's open up this identity, which is a square plus b square plus 2 into a into b upon x square plus 2x square is equal to 58 by 21. Okay, so if I cross multiply this is x square plus 4x square is 5x square plus 4x plus 1. This is actually x. So this is x plus 2x square. So 5x square plus 4x square. This is 5x square plus 4x plus 1 upon x plus 2x square is equal to 58 by 21. So if I cross multiply this, this is okay. So 21 into 5 is 105 x square plus 21 into 4 is 84x plus 21 is equal to 58x plus 58 into 2 is 8 to the 16, 5 to the 10, and 11. Okay, so let me take all these to the right hand side. So 116x square minus 105x square plus 58x minus 84x is minus 21 is equal to 0. So 116 minus 105 is 1, and this is 11x square 58. This is negative 14 minus 8 is 6. 7 minus 5 is 2. So this is 11x square minus 26x minus 21 is equal to 0. Okay, now let's try to solve this quadratic equation. So A is equal to 11, B is equal to negative 26, and C is equal to negative 21. And A into C is 11 into negative 21, which is negative. So 11 into 21 is 2 to 1. So this is 2 to 1. And we have to find the factors of 2 to 1 such that their product is 2 to 1 and the total is 26. So this is the factors are for 2 to 1, the factors are uh, 2 to 1. This gets divided by 7. So 7 3s are is 21. Okay, no. So 11 into 21, uh, this is actually 231. Okay, for 231, this gets 3 7 are is 21, then 77 and 7 and 11, and this negative 231, and the factors are 21 and 11, or 33 and 7. So 33 minus 7 is 26. So the factors are 33 and 11, and it's negative 33 and 11 are the factors that will give me negative 33 into 11 is equal to negative 231, and negative 33 plus 11 is equal to negative 26. So I'm going to solve this using the factorization method. So instead of negative 26, I'm going to put these factors, which are negative 33 plus 11x minus 21 is equal to 0. So 11x minus 3 plus 11. Okay, here common is both these. This is 33, and actually this is the factors were 3 7 7 and 7 and 11. So the factors are 33 and 7. So this is actually 7. The factors were 33 and 7. Okay, so minus 33 into 7 is negative 231, and minus 33 plus 7 is negative 26. Sorry for that. So this is 7 is common in this case, and common is x minus v. We are left with 11x plus 7 is equal to 0. So either x minus 3 is equal to 0, or 11x plus 7 is equal to 0, which gives x is equal to negative minus 7 by 11. So this is ignored, and x is equal to 3. So that means our numerator is 3, and denominator is 1 plus 2 into 3, which is 7. So the fraction is, we have to find the fraction. So fraction is 3 by 7. So 3 by 7 is the fraction for this. Let's move on to the next question. For question number 33, we have to prove, state and prove. State means we have to write the statement and then write the proof. This was 5, these are 5 marks. So this is the basic proportionality theorem. And we know that it states that If a line is drawn parallel to one side of a triangle and, and to intersect other two sides in two distinct points, then the two sides are divided in the same ratio. When the two sides are divided in the same ratio, this is the PPT theorem. And now we are going to prove that. So for that, I'm going to draw a figure first and we will do some construction. So this is the triangle ABC. A line is drawn parallel to one side of the triangle to intersect the other two sides in two distinct points. So let this triangle be ABC and DE is parallel to BC to intersect the other two sides at D and E. Then the ratio AD upon DB is equal to A upon AC. BC. So what is given to us is that DE is parallel to BC and we have to prove that AD by DB is equal to AE by AC. For that, let's do the construction. And the construction is we have to draw DM and EN perpendicular. So I have drawn DM and EN perpendicular to, so I have drawn, first one is DM. This is DM is perpendicular to AC and EN is perpendicular to AB. And I'm going to join B to E and D to C. So let me join these as well. Okay. Now, starting with the proof, I'm going to divide the area of triangle ADE by area of triangle BDE. So area of triangle ADE is half, and if I take AD as base, then EN is the perpendicular. So this is AD into EN. Upon this is half into area of triangle BDE. If BD is the base, then this is obtuse angle triangle BDE and its height is outside. So its height is EN. So we are left with AD by DB. This is equation 1. Okay, again, I'm going to divide the area of same triangle and this time our triangle is triangle DEC. So, and for this time, going to take the base of triangle AD as AE. So this is AE into DM upon half into triangle DEC, which is EC, and its perpendicular is outside, which is DM. So this gets cancelled and it's equal to AE by EC. This is 2. Okay, so we have almost got the result. If these two sides, we are able to prove that if we can prove that these two sides are equal, then we have almost got our result. But these two sides are not equal, and the difference is these two triangles. Now, these two triangles area are equal because these two triangles are on the same base and between the same parallels, and we know that triangles on the same base and between the same parallels are equal in area. So the area of these two triangles, DBE and DEC, are equal because they are on the same base DE, and between the same parallels DE and BC. So this is our result 3, and reason we can write that these are triangles on same base D and between same parallels BE and BC, and these are equal in area. So instead of replacing the value, I can simply go and write that from 1, 2, and 3. I can write AD by DB is equal to A by EC, and this is our basic proportionality theorem. Let's move on to the next question. This is the question number 34. If our question number 34 is given that from a point on the ground, the angle of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building are 45 and 60 degrees. So let this be point on the ground, and the angle of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building. So let's say this is the building that is 20-meter high. Okay, and this being the building 20-meter high, and there is a transmission tower fixed at the top of this building. Let this be the transmission tower. So AB is the transmission tower and BC is the height of the building. Let's join this point on the ground to the foot of the building. And from here, there are the angles of elevation to the top and bottom of the transmission tower. And the angle of elevation to the top and bottom are, this is 45 degree, and to the top it's 60 degrees. So this angle is 60 degree. And this height of the building is 20 meter. We have to find the height of the tower, that is AB. So to start with, let AB be height of transmission tower fixed at the top of building, height of tower, and BC is equal to 20 meter, be height of the building. Okay, and we are going to take the smallest one, that is a right angle triangle, the smallest one, which is ABC, this be D. So this is BCD. I'm going to use tan. So tan 45 is equal to BC by DC, and we know that value of tan 45 is 1. BC is 20. This is DC. We cross multiply this. So DC is equal to 20 meters. So DC is 20 meter. So this is 20 meter, and now we are going to take the bigger one, that is a right angle triangle. In right angle triangle ACD, once again we are going to use tan, but this time the angle is 60. So this is AC by DC. AC by DC. Now tan 60 is root 3 and AC is AB plus BC and DC. Okay, let's replace the values that we know. So AB is not known and BC is 20 and DC is also 20. So if we cross multiply this, this is AB plus 20 is equal to 20 root 3. Now AB is equal to 20 root 3 minus 20, which is 20 into root 3 minus 1. Meter is the height of the transmission tower. Okay, moving on to next question. That is question number 35. For question number 35th, part A, it's given that a solid iron pole consists of a solid cylinder of height 200 centimeter and base diameter 28 centimeter, and which is surmounted by another cylinder of height 50 centimeter and radius 7 centimeters. So question looks like this. There is a cylinder of bigger diameter, and there is one more cylinder at on top of this, and this is our pole. This is how the pole looks like, and this is the lower cylinder, and on top of that is one more cylinder. Okay, for uh, now this is our pole. So this is the pole. This is the pole which consists of two cylinders, and the first cylinder's height is 200 centimeter and base diameter is 28 centimeter, which is surmounted by another cylinder of height 50 centimeter. This is 50 centimeter, and its radius. Now its radius, remember it's the radius is 7. For we have to find the mass of the given pole, given that 1 centimeter of iron has approximately 8 gram of mass. For that, let's find out the volume of pole first. So volume of pole should be the volume of the lower and the upper cylinder, and the volume of the cylinder is pi r square h. So this is pi into its radius is 14, so 14 into 14 into height is 200 plus pi into its radius is 7, so this is 7 into 7 and its height is 50. Okay, I can take pi common, so this is 14 square into 200, and we know that 14 square is 196. So this is 196 into 200 plus 7 is 49 into 50, which gives me 5. So 196 into 2 is 6 to the 12, 9 to the 18, and 6 to that is 12, 9 to the 18 plus 1 is 19. This is 3. 0, 0 plus 49 into 50 is 9, 5 that is 45, 5 4 the 20 and 24 0. So this is equal to 22 by 7 into, if I add them, 0 plus 0 is 0, 4 plus 0 is 4, 4 plus 2 is 6, 9 plus 2 is 11, and 416400 and 41640. If I divide this with 7, which gives me, okay, so this is, let me just verify this. This is 196 into 200, which is 39,200, and 49 into 5 is 2. Okay, this should be 2450. This is actually 2450. And now if I add them, so if I add 39200 with 2450, which gives me 41650. So this is 41650. And if divided by 7 gives me 5950. So this is 5950. And if I multiply this 5950 into 22, will give me 130900. So 130900 centimeter cube. So this is 130900. 130900 centimeter cube is the volume of the pole. Okay, so we have got the volume, and now it's given that mass of 1 centimeter cube is 8 gram. So mass of 1 centimeter cube is equal to 8 gram, and we have to find the mass of the pole whose volume is 130900 into 8. So this is 0098 is 72, 8 3 is 24, and 10 gram. And if I convert this to kg, So that should be 1047.20 kg. So this is the mass of the pole, 1047.2 kg. Okay, moving on to the next question. That is the part B of the same question, question number 35. Okay, for the same question, that is question number 35, part B, it's given that a medicine capsule is in the shape of a cylinder with two hemispheres stuck to its two ends, and the length of the entire capsule is 14 mm, diameter of the capsule is 4, and this is the diameter of the capsule, which is 4 mm, and we have to find its surface area as well as its volume. Okay, so radius of hemisphere and radius of cylinder are same. So let me just write it down. Radius of hemisphere. So this is question number 35, part B. And there are two hemispheres stuck to two ends. So radius of hemisphere is equal to the radius of the cylindrical part. So that is equal to 2 mm. Now length of the cylindrical part. Now the length of the total length is 4, and this is 2 mm here. This radius is 2 mm here. So if we subtract 2 mm and 2 mm from both the ends, we are left with the length of the cylindrical part. So 10 minus 4 is equal to 6 mm is the length of the cylindrical part. Now let's find the surface area of capsule. So surface area of capsule is equal to the curved surface area of cylinder plus curved surface area of two hemispheres. So this is the curved surface area of the two hemispheres. Now the curved surface area of cylinder is given by 2 pi RH. So this is 2 pi RH, and these are 2. So 2 into curved surface area of hemisphere is 2 pi r square. So if I take common in this, which is 2 pi r, and we are left with h here, and 2 and r. Okay, let me just replace the values. So 2 into 22 by 7 into r. R radius is 2. Height is height of the cylinder, which is 10. 2 into r is 4. So this gives me 2 into 22 by 7 into 2 into 14. So 17 that is 14. 2 to the 4, 4 to the 8. And 22 into 8 is 176 millimeter square. So 176 millimeter square is the surface area of the capsule. We have to find the volume of capsule, which once again will be the volume of cylinder plus volume of two hemispheres. Now the volume of the cylinder is pi r square h, and these are two hemispheres, so 2 into 2 by 3 pi r cube. Okay, so this is 2 by 3 pi r cube. So this is equal to pi r square h plus 4 by 3 pi r cube, and the common is pi r square. So this is h plus 4 by 3 and r. Okay, replacing the value gives me 22 by 7 into radius is 2, 2 square is 4, height is 10, 4 by 3 into 2. Okay, so this is 22 by 7 into 4, and this is 10 plus 8 by 3. So 22 by 7 into 4 into this is 38 by 3. Okay, so if I multiply these two, this gives me 7 3 is 21, and 22 into 4 is 88 into 38, and if you multiply 88 into 38, so 88 into 38 should give me 3344. So this is 3344 divided by 21 in millimeter cube, and if we want to get this in decimals, so getting this in decimals is 3344 divided by 21, which should give me 139.33. So 139.33, 3344, sorry, 3344 divided by 21 should give me 159.24. So this is 159.23. This was 238, 238 millimeter cube. And if I round it off to two decimal places, this should be 159.24 millimeter cube should be the answer. Okay, so moving on to the next section, that is section E. Okay, for section E, this section consists of three study-based questions of 4 marks each. And coming on to question number 36, it states that a stable owner has 4 horses, 1, 2, 3, and 4 in the figure. And usually these tie these horses with 7-meter long rope. So this is the 7-meter long rope, that is each horse can graze up to here, the distance up to which this rope can extend, and there are pegs at each corner of a square. So the pegs are maybe the wooden or some metal rods that are stuck into the ground uh, to tie these horses. And there's a square shaped field of 20-meter length, and these horses are grazing in this field. But by tying with rope sometimes there's an injury, so he decided to build fence around the area so that each horse can graze. So this is the fence around the area. Based on the other information, we have to find the area of the square shaped field. So area of the square shaped field is, this is the square. So area of square shaped field is side into side. So its length is 20. So 20 into 20 is 400 meter square. So this is 400 meter square is the area of the square shaped field. Now we have to find the area of the total field in which these horses can graze. So the area in which each horse can graze is in the form of the sectors, and there are 4 sectors, each with central angle 90 degree. So this is part A of the second question, and we have to find area of total field in which these horses engage. There are 4 sectors, and area of each sector is theta, which is 90 by 360 into 22 by 7, and radius is 7. So 7 into 7, this is 4 gets cancelled, and this is equal to 154 meter square. Or the part B says, if the length of the rope of each horse increase from 7 meter to 10 meter, find the area grazed by one horse. So area grazed by one horse. It's not the increase in the area, it's just the area grazed by each horse or one horse. So this is equal to, it's just the one horse. So theta by 360 into 3.14 into, now the radius is 10. So this is equal to 4, and this is 314 divided by 4 meter square. So 314 divided by 4, if I divide this with 4, this is 4 7 is 28 and 34. is 4 8s are 32.27.78.5 meters square is the area grazed by the horse, each horse, if the length of rope is increased from 7 to 10. Okay, and we have to use 3.14, which we have used the value of the pi. What is the area of the field that is left ungrazed if the length of the rope of each horse is 7 centimeter, which is not possible. 7 centimeter is a very small length, and this cannot be the rope of. So I'm going to consider this as 7 meter. You may consider it as 7 centimeter, and so if I consider the length of the rope as 7 meter, then the area uh, grazed. This was the area of total field in which horse can graze when it's 154. So area left in ungrazed is the total area minus the area of total field in which the horse can graze when the length of the rope is 7 meters. So I can write this is the area left ungrazed because 7 centimeters is a very small length, so it cannot be 7 centimeter. It should be actually 7 meter. So the total area of the field was 400, and the area of the total field with the four horses can graze with the length of 7 meter is 154. So this is 400 minus 154. So 400 minus 154, 10 minus 4 is 6, 9 minus 5 is 4, and this is 3 minus 1 is 2, 246. 246 meters square is the area left in ungrazed. Let's move on to question number 37. Okay, for question number 37, it's given that vocational training complements traditional education by providing practical skills and hands-on experience. And while education equips individuals with a broad knowledge base, vocational training focuses on job. So this is all about the vocational trainings. And there is data that is made by the teacher about the frequency distribution of students or the adults uh, who are undergoing vocational training from a training institute, and the data looks like this. So this is the data, and this data is not continuous because 15 to 19, 20 to 24, these are not the continuous class intervals, and we have to find the lower limit of the model class and the median class and the median class of the above data. So I'm going to prepare this data here. So this is the first column, which should be age in years, and the second should be the frequency, which should be the number of participants. And this is the first column is age, and this is in years. Because this is not continuous. So I'm going to make it continuous by subtracting minus zero point 0.5 from the lower limit and adding zero point 0.5 to the upper limit. So subtracting zero point 0.5 from the lower limit of the first class interval, it gives me the data as 14.5. So this is 14.5 to 19.5. And then for all the class intervals, subtract zero point 0.5 from the lower and add zero point 0.5 to the upper. So this is 19.5, 20.5, then 20, okay, this is 19.5 to 24.5, and this is 24.5 to 29.5, 29.5 to 34.5, 34.5 to 39.5, and 39.5 to 44.5, and 44.5 to 49.5, 49.5 to this is 54.5. Okay, this is the data. Let's put down the frequencies. Okay, the frequencies are 62, 132, 96, 37, 13, 11, 10, and 4. Okay. Now we have to find the lower limit of the model class. So the model class here is the one with the maximum frequency, which and the maximum frequency is 132. So this is the model class, and we have to find the lower limit. So lower limit of the model class is 19.5. So this is 19.5 is the lower limit of the model class. Okay, now coming on to the second part, we have to find the median class of the above data, and to find the median class above the above data, so we have to find the median class of the above data, and for this we have to find the total number of participants. To find the total number of the participants, we have to find the cumulative frequency. And to find the cumulative frequency, let's write down the first frequency 62. 62 plus 132. Let's add them. And 62 plus 132 is, okay, 62 plus 132 is 4, 194. And 194 plus 96 give me 6, 4, 10. 9, 9, 18, and 19, and it's 290, and 290 and 37 gives me 7, 9, 3, 12. It's 327, and 327 added to 30 gives me 7, 3 is 10, 2, 3, and 4. This is 340. 340 added to 11 gives me, it's 1, 5, 351. 351 and 10 gives me 361, and 4 is 364. So our total is 364. 361 and 4 is 365. Sorry. So our total is 365. And let's calculate the half of this n by 2. So this is n. So n by 2 is 365 by 2, which is 2 on the 2, 8 are 16, 2.182.5. So 182.5 n by 2 is, okay, 182.5. We will get 182.5 after 62. So our median class is the same, 19.5 to 24.5. So the median class is same, which is 19.5 to 24.5. Okay, moving on to the next question. It's asked find the number of participants of age less than 50 years who undergo vocational training. So less than 50 years are these, all these. So less than 50 years. This is question number seconds part B. Question number seconds part B. And less than 50 years, the candidates are 62 plus 132 plus 96 plus 37 plus 13 plus 11 plus 10. Okay, so all these are less than 50 years, all these including 62. So if I add them, which gives me 3, 4, and 7 is 11, and 6 is 17, 2, 19, and 2 is 21. So this is 21, 6 to 8, 3, 11, and 9 is 20, and 3, 23, 24, 25, and 26. So this is 26, and this 2 plus 3 is 2 plus 1 is 3, so 361 are the total candidates who are less than 50 years of age who are undergoing vocational training. We have to give the empirical relation between mean, median, and mode. And the empirical relation between mean, median, and mode is given by the formula. So empirical formula for mean, median, and mode is given by 3 median. It's 3 median is equal to mode plus 2v. This is the empirical formula. So we are dealing with question number 37. Moving on to question number 38, which is the last one. Question number 38. It's given that teaching mathematics through activities is a powerful approach that enhances students' understanding and engagement. And keeping this in mind, Miss Mukta planned a prime number game for class 5 students. She announces the number 2 in her class and asks the first student to multiply it by a prime number, then pass it to second student. Second student also multiply it by a prime number and pass it to the third student. In this way, multiplying these the successive prime numbers, the last student got 173250. Now Mukta asks some questions. What is the least prime number used by the students? So let's get the factorization of one prime factorization of 173250. That will give us the prime numbers used. So this is 2, 8 are is 16, 2 6 are is 12, 6 are 12, and 5. Okay, so next is 3. So 3 twos are is 6, 26, and 3 eights are 24, 26, 3 eights are 24, 3 sevens are 21, and 15. And this once again goes by 3. So this is 3 once again. 3 nines are is 27, 6 are 18, 3 to the 6, and 5. Now it goes by 5, so 5 ones are is 5, and 46, 5 nines are 45, 5 twos are 10, 5 fives are 25, 5 threes are is 15, 5 eights are 14, 5 fives are 25, 5 sevens are is 35, and 5 sevens are is 35, and 7 into 11. Okay, so I can write down the prime factorization of 173250 as 2 into 3 square into 5 cube into 7 into 11. So what is the least prime number used by students? So here the least prime number is 2, but this was not used by the student. This was announced by Miss Mukta in her class. And the first student uses the least. So the least prime number, these are the prime numbers used by the students. And the least prime number used by the students is 3. Okay, moving on to 2. How many students are there in the class? So number of students there in the class would be the number of times these prime numbers are used, and the number of students are the powers 2 plus 3 plus 1 plus 1, which gives me 5, 6, and 7. So the number of students in the class are 7. Because 3 is used 2 times, 5 is used 3 times, 7, 1, and 11, 1. So just adding the powers give me the number of students. Okay, and it's or what is the highest prime number used by the student? These are the prime numbers used by the students, and the highest prime number is 11. So 11 is the highest prime number used by the students. And which prime number has been used maximum times? The prime number that has been used maximum times would be the one with the maximum power. And for question number third, the prime number that has been used maximum times is 5 because it's been used 3 times. So the prime number that is used maximum number of times is 5. And with this, we have solved this question paper, which was the third set of 2024. Thank you for watching.